Okay, this is not a kit, so we're doing the elevator. We're gonna talk a little bit about the grain of the wood. I had this piece here. It's the angled piece right here on the back side of the elevator, and it has an angle this direction so that it can go up and down. And the opposing part also has an angle. You see that angle? But anyways, this one here is only about 10 degrees to 12, and I really wanted it 13 or 14 degrees, maybe a little more. And this one here I cut at the same time. So I'm going to cut a new piece, but not so much because of the angle, it's because of the grain. Look at the grain on this piece of wood. You see that grain? Everything is wrong with this grain. First of all, there's not enough grains per inch, growth rings per inch. See how angled that is? That's far too much. It's 15 inches over 1 inch, 1 in 15. So over a 15-inch length, it can't move more than 1 inch. And this here, right here, is 3/4 of an inch wide, or just under it. So you can see it crosses that, but that's only like 8 or 9 inches. So that's one thing. The other thing is, this is commercial white ash, and it's about the same as Sitka spruce. You want 6 growth rings, minimum of 6 growth rings per inch. So I don't have enough growth rings, and the grain is going across the board. It's moving. Geez, oh man, let's see if I can get a non-glare view of this. Anyway, so I'm going to recut it, and there we go. Need to do it over. Look at that. Look at that terrible grain. Look at that. That's terrible. And so I'm going to replace it with this. Now, big difference. Look how straight that grain is. And that's the whole length of it. And that's about 9 growth rings per inch of width. So, anyways, I'm going to recut one of these with the angle on the back of it out of this piece. But this is all set up. I wanted to show you how you want to set things up to make sure you get the most precise cut. My blade is at 15-degree angle. Yeah, you can see it here, 15 degrees. And I've got feathering boards, and this one here is going to hold it down with a little more power down than this one. This one's real light, holding it against the fence. But that'll get me the most accurate width, and this here will get me the most square, because the blade is square to the table more than it is the fence. Let's see. So you can see an enormous difference between the two. So now we just want to measure that little bit of angle where that beam is here, back beam here. Oh, right there is going to match up. But we're going to measure both of them independently, because there might be a 1/2 degree variation. We want that joint, even though that's not the structural joint, we want that joint to be as good as it can be until we get it gusseted and blocked in. So I remeasured this, and it's actually about 9 degrees, 9.5 degrees, and you can see if you can see down in there. It's like virtually a perfect joint. I hate calling anything perfect, but because it's 9 degrees of an angle out that way, I've got this clamp, and there's a little bit of pressure pushing in, but it's right on that black line of the print. You can see that, and the other side also. But really good joint. And of course, that clamp there is holding it. And I was just going to show you my favorite application and stirring stick here. Just take a piece of geodetic, I thin it down like a blade, put an angle on it, and then square the tip of it, and then I do a lot, like for all these pieces back here, gluing up all those strips, and just use it like a putty knife, and just like this. It goes real quick.